Hey Kinders, please watch this video all the way to the end because I'm going to show you the most effective way to master the multiplication table. And this has nothing to do with memorization. Actually, it's the same process that I use to help my own kids get months and possibly years of memorization struggle. So, do you recall learning your multiplication facts back in grade school? Like me, you probably resorted to the traditional methods of making flashcards, cutting out times tables, and cranking out stacks of worksheets, all in the simple pursuit to grasp elementary math. But the problem with memorization is exactly that it relies on a student's memory, which is not only different for every student, but fluctuates greatly according to diet, rest, and stress levels. And some curriculums make students memorize times tables up to 20, which means 210 different outcomes to memorize. Now, if that doesn't stress you out, try doing 100 problems in 60 seconds, a common benchmark for fact fluency. Another problem with memorization is that it undermines the very concepts that bridge a person's mathematical awareness toward relevant application. For example, memorizing the value 21, the outcome to 3 times 7, ignores the very concept of space and time. What? Now, before you break your phone in half, simply put, 3 times 7 is the occurrence of 3 at regular intervals until 7 modules of 3 have elapsed. Space and time. So, the issue is that fact memorization focuses on what the answer is, but truly understanding math is much more about the why of a problem rather than the what. So, is there an easy and surefire way to produce the facts of multiplication no matter the problem, the day, the time, or whether or not your big sister is hogging the iPad? Well, it boils down to 2 very simple techniques. The first technique is counting. Counting is the successive naming of intervals. We humans understand counting because it goes into the concept of modularity and serialization. We innately understand things that happen in regular order. But counting doesn't stop at just counting by ones, but counting by other intervals as well. For instance, we teach students to count by 3s. The intervals are 0, 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. We do not ask students to add 3 or do any kind of calculation. We simply ask the student to count. And because we use fingers while counting, which, by the way, is not cheating, the student can count up to the value of 30 and set in place a reliable and permanent method to garner any multiple of 3. Fundamentally, this opens the child's mind to the world of core competencies of math, which I cover in another one of my videos. Now, it might take your kid a few tries to get this down, but once she does, she rarely forgets it. So, you may be thinking, wait a minute, are you saying that my kid has to learn to count by every factor of every multiple from 1 to 10 and possibly up to 20? And isn't this just another form of memorization? The answer is no. Mainly because of the second tried and true technique that we use to help students master the multiplication table. The technique is called doubling. Doubling is another built-in feature of human thinking because it goes into the concept of symmetry. All vertebrate animals have symmetrical body shapes and are naturally adept to selecting others of its kind based on their preciseness of symmetry. In other words, symmetry is the mathematical model of beauty. In a numerical sense, we can simulate the ideas of symmetry with halving and doubling properties. Now, how do these 2 techniques combine to create a complete and beautiful knowledge of the multiplication table? Well, take the problem 6 times 7, for example. Since we have already learned to count by threes, we simply count by threes up to 7 fingers or 21 and double it for 42. Likewise, the student can count up to any multiple of 2 since it's 1's double, and any multiple of 4 since it's 2's double, and any multiple of 8 since that's 4's double. Using the doubling technique, together with counting by 1s, 3s, and 9s, gives your math learner a total coverage of the multiplication facts table. But wait, where are the multiples of 7? Well, since it does not matter which factor comes first in a multiplication problem, all multiples of 7 are covered elsewhere in the multiplication table. Except for 7 times 7, that is, which is really the only fact you might memorize by rote. Until a bit later, anyways, when we get to learn to count by perfect squares. Incidentally, counting by perfect squares not only takes care of 7, but the square of 11, 13, and 15 as well. So, that's about it for the theory. Now it's time to put the theory to practice. So, give the exercises coming up a try and remember to practice during free moments throughout your day. After a few sessions, let me know down in the comments what new and interesting things you start to notice about your child's math ability. As always, thanks so much for watching, and now, let's get crazy with some math.
Face your child and say, let's play a doubling game. First, start with some naming questions. Ask, what is the double of 21? Did she say 42? If not, follow up with, what is 21 made out of? The answer is a 20 and a 1. Say, if the double of 20 is 40, and the double of 1 is 2, then the double of 21 must be 42. You can also double 21 by counting by 2s up to 21 fingers. Continue with, what is the double of 32? Did she say 64? How about the double of 24? Did she say 48? And the double of 18? Did she say 36? Lastly, what is the double of 28? Did she say 56? Link into the complete multiplication facts table with naming the multiples of 3 and 4 and doubling the answers. Ask, what is 7 threes equal to? She is counting by threes up to 7 fingers. What is 7 sixes equal to? She is counting by threes up to 7 fingers, or 21, and doubling it to get 42. What is 8 fours equal to? She is counting by fours up to 8 fingers. What is 8 eighths equal to? She is counting by fours up to 8 fingers, or 32, and doubling it to get 64. What is 6 threes equal to? She is counting by threes up to 6 fingers. What is 6 sixes equal to? She is counting by threes up to 6 fingers, or 18, and doubling it to get 36. What is 7 fours equal to? She is counting by fours up to 7 fingers. What is 7 eighths equal to? She is counting by fours up to 7 fingers, or 28, and doubling it to get 56. After some practice, mix and match with other multiplication facts. For example, what is 6 times 5? She is counting by fives up to 6 fingers. What is 6 times 4? She is counting by fours up to 6 fingers. What is 6 times 8? She is counting by fours up to 6 fingers, or 24, and doubling it to get 48. She can also count by threes up to 8, also 24, and double that to get 48. Make up some more problems on your own, and remember to practice during free moments throughout your day. Subscribe to Kinder's Guide for daily and weekly exercises, tips, and math hacks. Link up the recommended resources and materials in the show description.